Good afternoon, everyone. Myself, Pradeep. I'm leading the site reliability engineering team at Freshworks. My friend Raghav and I are here to give a talk about meeting service level objectives with HAProxy and combination of Redis. Unlike all other sessions, ours will be focusing more towards systems and operations rather than application development. We are from the SRE team, and wherever we go, we mostly talk about availability. So before the actual talk, I would like to give an introduction about Freshworks. So Freshworks is a B2B SaaS business. We started in 2010 with a single product, and as of today, we have close to 11 products. So far, we have received $50 million in funding. We have been backed by Axel, Tiger, Sequoia, and Google Capital. And we are always proud that we are the first company outside US to be backed by Google. And we have 2,000 plus employees, and we have 197 is the number of countries where we have customers from. And as a total, we have 150K happy customers overall. Okay, so these are a few of our famous customers. Hamleys take the top spot as it's Redis Day London. And initially, one on the right bottom, I'm not talking about Cisco, I'm talking about Redis Labs, is also a happy customer of Freshworks. I initially had Redis Labs as one of the logos, and with the latest template that Dave gave me, the logo was stamped in all the slides, so I just moved it to the bottom. Okay, so this is the scale that we have seen so far. This is a number of requests that we used to receive per week. So I joined Freshdesk in 2013. When I joined Freshdesk in 2013, for the entire week, we used to receive 500,000 web requests. That's the exact same amount of traffic that we handle per minute during the peak load as of today. So this is the kind of engineering scale that we have seen over the past few years. And few more engineering numbers. As I mentioned, we handle 500,000 web requests per minute, and we do 10 million MySQL operations and 8 million Redis operations. And we generate and manage close to 30 terabyte of logs per day. So this is the engineering scale that we operate today. Okay. How many people here are from a SaaS background? Okay, cool. There are a few hands. Let me explain how Freshworks is different from other SaaS business. So we are a B2B SaaS business, but our customers can be B2B or B2C. At times, it's both. So today morning, Parin gave a talk on Book My Show. So Book My Show is also a customer of Freshworks. So let me explain how Book My Show is a B2B and B2C customer both. Let's say you are booking a movie ticket, and the payment is done, but for whatever reason, you are not getting the booking ID. So what you will do is you will be raising a support ticket, or you will be clicking on the help button within your mobile app, right? So that will be a web traffic to Freshdesk. That's an example of an B2C use case. Let's say for the same Book My Show, a movie operator or a theater owner is updating some offers for the weekend, and it's not getting reflected in the application. So the owner again will raise a support ticket, right? So that's an example of an B2B. So it's the same customer, can be B2B and B2C, at times it's both. So traffic for us in most of the cases will be unpredictable. So that's the reason I'm explaining the nature of business here. Okay, so this is the architecture of Freshworks that we have. So all our UI components, JavaScript, CSS, images, everything gets rendered to the web app or the mobile app using CDN, and all API requests comes to a load balancer. So as soon as the request reaches the load balancer, we have a reverse proxy cluster. We use HAProxy as a reverse proxy. So as soon as the web request reaches HAProxy, it will be forwarded to the web app cluster. So between the reverse proxy and the web app cluster, we use a throttling service. And apart from that, we have a spam detection service, and we run multiple microservices. And as soon as the web request reaches the web app layer, depending on the nature of the request, it might contact database, Redis, Memcache, or multiple microservices before it gives the actual response. And the response again will be sent back to the HAProxy, from the HAProxy to the load balancer, and at the end it will go back to the web app. So this is a high-level architecture diagram of Freshworks, and from here I will hand it over to Raghav.
Hey, thanks Pradeep. So hi folks, ever heard of Murphy's Law at some point or the other? Okay, slides are right here. Okay, so I'll start my discussion by stating Murphy's Law, which says something like, anything that can go wrong will go wrong. So as a company operating at the scale that we are at, and the diverse nature of traffic that we receive from our customers, we need to have this in mind when we design our systems. Will we receive spam traffic? Most of the times, yes. Will there be spikes in traffic at times? Yeah, we do have at times. Will there be any failure in some part of the system? At times we do. So as the SRE team, we need to be able to handle all such cases and maintain high availability for the product. So our primary product is Freshdesk, which is a customer support platform. So which means ticketing is our main workflow. We support different sources, email, Twitter or Facebook, and then chat are a few to name. So let's take the email workflow. So we do get a lot of spam emails all the time. So as soon as an incoming email hits our system, the app cluster talks to the rate limiter service, which in turn talks to the spam scorer service and decide whether or not that particular email could be converted to a ticket in the system. So we do have rate limits at different levels. So we have rate limits on a tenant level on the number of tickets that can be created. Going a little bit granular, we do have limits set for users of a tenant. Ticket is one such entity in our system. We have other entities like solution articles, for example. So beyond the set limits, we throttle customers. The rate limiter service talks to the spam scorer and maintains a score depending on the number of throttlings that happen in a given period of time to decide whether or not to blacklist that user. So the cooling period is a dynamic base, which is done based on the score. We run Lua scripts inside Redis, which uses sorted sets with timestamp based scores and other data structures with TTLs to achieve this. So for a company like us, if we don't throttle, well, we have proper throttling and rate limiting mechanisms in place. We have plan-based minute level and hourly throttlings, rate limits, and beyond which we throttle. So when we say we are a multi-tenant architecture, which means that we have a lot of small customers who generate small traffic, and as well as there are a lot of large premium customers who generate huge loads of traffic, which is all dependent and runs on the same underlying system. So we need to maintain high availability for all our customers. One large customer generating a huge load could start affecting other smaller accounts, which could lead to the noisy neighbor problems. What we do, we are able to identify such traffic and patterns and are able to isolate and route such traffic onto a separate buffer cluster with HAProxy, Redis, and Go. By doing this, we are able to meet the SLOs and in turn the SLAs for all our customers. Redis is the backbone store for this system. All of this intelligence goes into the design of the reverse proxy system that we have. So I discussed a few problems that arise from inbound traffic, which could lead to degradation of the availability and how we tackle it. I'll pass it on to Pradeep, who will discuss how we tackle internal system failures and maintain high availability.
Thanks, Raghav. Let's see how we tackle failures at the system level or other database level failures. Okay. If your system goes down, your business doesn't have to. So what we are talking here is, let's say for whatever reason your SLO gets affected, your SLA doesn't need to get affected. Because you might be running hundreds of components within the infrastructure. Maybe a SLO of a particular component gets affected, let's see how we tackle those failures. So in most of the cases, these are three primary areas where we get failures: database failures, failures at microservices, or failures at third-party levels. We'll be discussing only about the database level failures here. Okay. Ours is a heavily sharded application. We have the entire sharding logic built into the application. This is how the traffic comes. So all the traffic for any set of customers comes to the Redis proxy. From there, we have a common web app cluster. In this diagram, we have mentioned three shards: shard 1, shard 2, and it goes all the way till shard n. Let's assume there is a failure at shard 2 here. So all the SLO that we have set for any MySQL calls is 10 milliseconds. And let's assume there is a hardware failure at shard 2, and obviously the response time that you will get from that shard 2 will be greater than 10 milliseconds, and you will not be able to meet the SLO. What happens here is we don't have any restrictions on the web app cluster layer stating that only this set of servers should serve this kind of request, or only shard 2's request should go to this combination of servers. So let's say shard 2's request on a normal scenario will go to any of the web servers here. In this case, the entire web app cluster's overall response time will get slowly affected. So basically, the failure will cascade across the entire web app layer. So that's what will happen in a normal scenario. So what we have done here is, so we again use a combination of Redis plus HAProxy plus Go, and for whichever the shard that we have failure, HAProxy will immediately spun up an emergency cluster, and it will has the capability to redirect a failure or the SLO affected shards traffic alone to a different cluster. So this is what we have done. But till now we haven't told how we have achieved this exactly. Let me explain that. Okay. So this is what happens behind the scene. For every web request that we get, we log in a line like this. So it will have a timestamp. It will have the unique ID, domain, path, client IP, and what's the overall duration it has taken to process this particular web request. So we have this entire information logged in a single log line. Let's say the SLO that we have set for any web request is 100 milliseconds. This particular web request has taken 259 milliseconds. It has impacted the SLO. Let's see, that's because in this particular web request, database has taken 150 milliseconds, and even in the database, it's the shard 2 that's getting impacted. So these are the three information that will get captured, and this information will be stored in Redis. So the kind of information that we'll have is, for the previous minute, shard 2 has impacted or violated the SLO for 10,000 times. This particular information will be communicated back to the reverse proxy, which is the HAProxy using Go. So HAProxy will get to know that, okay, there's a problem with shard 2, and it's time for it to spawn an emergency cluster or redirect that particular shard's request alone to a different cluster. So this is what happens exactly behind the scenes. So what we have done is, we have brought the entire infrastructure's context at any given point on time, and we are feeding that information into Redis. Redis, again using Go, will pass on this feedback or pass on this information to the HAProxy, and that will execute some scripts or create some dynamic configurations on the fly and do some routing so that the overall SLA is not getting affected. Thank you.